Hey there, this is Terry, and this video will be about how I use or implement Obsidian Cursor at the same time to help me learn more, learn in a better and more efficient way. I think it's a really interesting workflow, so I recorded this video and maybe I upload it onto social media or platform. In case you don't know, Obsidian is a note-taking application mainly for PC, and Cursor is an AI IDE, which kind of mix coding and AI at the same time. So like have an AI agent or an AI assistant. You can see I can talk to AI and AI can read what I write, not only codes but also markdowns, texts, and other form of things. It's really convenient. It's very efficient, and maybe you'll be interested in this. At the same time, I will also talk about what I learned from a very old-fashioned book called Hands-on Machine Learning. So maybe you will learn from this video, but I think mostly you won't. Hello, this is Eric, and I'm going to record a short video about my first chapter learning about the book Hands-on Machine Learning, and this file is written on Obsidian. Most of the notes are actually saved on margin notes on my iPad, so in fact the note is for AI so that I can understand what is included and can possibly reproduce a similar one afterwards. So for chapter 1, it mainly gives introduction to the topic, including the definition of machine learning and the categories of different types of machine learning. So this video is also going to showcase the entire workflow of my learning process. So I think I'm also going to put the definition of machine learning here as the subtitles. So be careful that you don't have to be very comprehensive. You don't have to write every details. So I mean, for me, machine learning is just something. It's just computers learn from data without being explicitly programmed to do so. So yeah, I don't really know whether it is true or not, but the AI is going to do the calibration for me. I don't even know whether there's any typos, but I mean, AI will do the job for me, so I don't really give a fuck about it. Okay, go to categories. The first category is there are different categories, which means AI are divided into different things by different ways. There are different criterias. There are different criterias for it. So different criterias here. So the first one is going to be whether there is human supervisions. The first one is of course supervised machine learning, unsupervised machine learning, semi-supervised machine learning, reinforcement machine learning, machine learning. So I'll give more explanation here. So it actually means given a reward plus penalty system. Examples are like a walking robot. In this case, a performance measure is required. So you basically have to measure whether it reaches how good it has done the job. So in this part, okay, I'm going to use in this part the book examples of the applications are also shown. You should be able to provide. So now I'll write in a different way. You should provide names for the applications of different kinds of machine learning. For example, visualization, clustering for unsupervised machine learning. Like for supervised machine learning, have like a the most famous OCR, like OCR for supervised machine learning. Give me that. Okay, so this is written for AI. I don't know the applications here, so I'm going to leave this test for the AI. So later on, the most ideal context will be the most ideal outcome will be the artificial intelligence complete this thing for me, and one AI read this text and he just immediately gives me what I want. Okay, let's go. And the second possible way to categorize will be so let me check. So online or batch learning. So yeah, this is interesting. This is interesting because I will note that online learning doesn't mean plugin, like connecting into the internet. You should explain what exactly differentiate online and batch learning here. So maybe to you it doesn't make sense, but you should actually trust AI. I believe he can do the job. So yeah, so this is another test I gave to AI later. Let's see whether it can do this. So let's first think about online learning. Sorry, let's start from batch learning. Okay, because batch learning is relatively different. So I think first it's not, there are a lot of disadvantages for batch learning actually. This first, training uses the full set of data. This actually indicate, this indicates hours of processing. The second thing will be, it also requires a lot of computing resources due to the same reasons above. So that is batch learning. And for online learning, I think for me, it it solves or tackles all the disadvantages of the batch learning. Basically tackled most of the problems of batch learning. So the case is how does it do it? How does it do it? So one by one, okay, one by one. So the first cons for the batch learning is a useful full set of data, so there are non-hours of processing it. All right, so one thing it can do is online learning is great for systems that receive data as a continuous flow. So yeah, maybe you don't understand what it means here, right? You don't understand what does it mean continuous flow. So that's where the AI should do some work. Playing what continuous flow means here, and justify why it can solve the problem of non-hours of processing. That's the first thing. So actually, I think I have some ideas for it. So I keep writing my ideas for it. This question so far. So why indicate the non-hours of processing? Because every time you try to train it to a better version, you have to use the old data plus the new data. So for batch learning, every time old data plus new data. For online learning, new data fed to the model. So the second advantages for online learning is I think sort of can break all the data into smaller parts. So data can be sort of broken into smaller pieces, like top-down design. Top-down design. Once model has finished the training, for a single piece of data, it can discard them. Like you don't need them anymore. So I think so this save more resources, I guess. Like for the space to keep them, to save them. That's just my ideas, and I think he can do more explanation based on my version. AI can do the update. And this actually has a name for it. So I'm going to add here that is called out of core learning. Oh. Let me think. So yes, there was a second kind of categories. So here we go to the third, was instant base or model base. So the key differences for like, oh no, I think 3 years for instant based learning. The first thing is requires a measure of similarity. However, it basically works by comparing the new with the old that exists in the database. Like, it basically do this thing of like by comparing. It is what it is does, so it requires a measure of similarity. So another thing is model-based learning. Definitely requires a measure of performance. Why? Because it generates a function or a model to predict something according to the input. And in this case, you will need a measure of performance. For instance, the most common is like the loss function, for example. Loss function like xi minus yi squared. Okay, that was a model base. I think people do the model base more often. Yeah, that is the end of the categories of it. Is that the end of chapter 1? I'm not sure about it. Actually, I mean something more about this. So I think within the chapter, the book also provides a lot of flowcharts, but you can draw them as well. Yeah, I'm talking to AI, but yeah, this is basically nonsense, so I don't write it. Viewers can check them on the book, in the book, like book. Nobody's going to read this note. I don't know. I don't see any point. Actually, this is talk to me myself. So that is the categories. That was the first thing. That's a second thing. But the first thing is about the definition. Like, okay, how to actually come on. I'm not very used to it. So like, what? Okay, fine. Not important. The third part of the book is about common mistakes. Basically, or challenges. I don't think it's a mistake. So challenges you might, developers might face. So I think the most common thing, the most like prestigious is overfitting and underfitting, or fitting and underfitting. So like for like overfitting, it's just basically you try to use like a polynomial with high orders to fit a linear regression. It's going to overfit, so it reflects on high accuracy on the task set, but low accuracy on the training set, but no accuracy on the test set. And underfitting, like you underestimate the complexity. Okay, I don't really want to write too much because I don't want to, so I will leave this to AI. You explain more here. Okay, more here about the concept. In precise words, precise and understood. I don't see the ways. I don't know. So, and the second thing I believe it will be I think the second thing is about the data, about the quantity of data. Like actually to train a model, you need a lot of data. That's the first thing. You need a lot of data. And there is something called the unreasonable effectiveness of algorithm of data or the data. Yeah, so it basically talk about how important data is. Oh my god. Explain here a bit more within 2 sentences. I will also talk about I think another challenge is non-representative data. That is to say, basically, the data is polluted, like there are some data we don't want, or they are noises. So I will leave another text for AI. Explain noises here within several sentences. Another thing is data mismatch. Data mismatch is, for example, I would just take the example from the book because I think that's a good one. You want to develop like an applications to identify the random flowers a user might see on his road, like for example on his way back home. You feed the model with thousands of pictures taken by professional cameras, but actually the real input will be what is taken from maybe like just a bad camera on an iPhone. That doesn't really match. but I will leave this the explanation text for AI. Explain. Okay. Here with examples. Short. Sure. Yes, I think that is basically the end. Basically the end of the chapter 1. This is the end of chapter 1. Okay. So yes, later I will give this, leave this text to AI and let it do the job. I will showcase my workflow. Hey, you see now I'm on my cursor, and actually this is the same files I have shown on my Obsidian. Why I shift to cursors, because I can just use, you see, my agent whenever I want. It's like AI agent, and he can just view my file and maybe change something on it really quickly and conveniently. Yeah, so let's see. So this is the files I write on Obsidian. It's very rough, but I think it's good. It's really good here. I think it's good. It's basically good. So I will show. I mean, this video is to show my workflow, and interesting. So, yeah, hands-on machine learning. So I will try to ask AI agent to do the job for me. It's so task. So first, yeah, I asked it to read this file about machine learning to correct all the most basic errors about typos and run and misinformation. The third thing is in the file I have already given you some prompts and tasks. Try to refine my notes based on by identifying the hints. So it's also important to tell him what you should not do. You should not do. Change my structures. Change my structures. Do not change my structures. Change my style. Use too many terminology and complex words, or write to none. Yeah, like here, please be short and precise. Pose and mark down grammar for Obsidian. So let me think. Like all in markdown grammar. And you're to get access to the internet. So yeah, let's try how whether it works really. Yeah, I like to see how it works. It's really interesting. I don't even know whether, I don't know. Maybe it's working. It's working, I think. It's working, and I think he has done some explanation, right? But you know, sometimes I don't know. Like, let's see. He has done so many things. Auto. I don't know. Am I satisfied? Let's check. Yeah, you see, I make some spelling mistakes for categories. Interesting. Different criterias here. Okay, so yeah, he does actually change my, does actually do some changes to my grammar. That's good. That's good. And he does remain my markdown grammar. Applications. I don't know, man. I mean, spam detection is good. I don't know, but it's better than this. But what I'm expecting here is quite different. But it's good. Like AI, sometimes have some miscommunication with AI, but no, it's good. So I will just keep it for now. Like, but it's not like no. So I will talk it with AI with this point. How to do this? What? Let's see. Oh sh. Ouch. Go to add symbol to new chat. Okay. So check here. I want you to add a longer list of applications of different machine learning to this part. So like this part straight after the bullet points thing. I hope you can get what I mean. For example, you should also mention linear regression for supervised learning. In fact, everything that is famous. I don't know whether I should use the word famous, but I think AI is good at understanding people. It's good at understanding parts of people, so yeah. Incrementally is a good thing. I'll keep it. So I mean incrementally like it's increasing, right? I understand, but I don't know what other people understand, but I will keep it. I don't know whether just keep it. It's not different. Oh, it's about, okay, grammar, fine. Continuous for data arrives stream by stream, solves model updates incrementally, not retraining on all data like batch learning. Like, I don't know. Sure. I think it's meaning about grammar. Fine. Yeah, but for import, this is important, I think. Keep. overfit in model, nerves, noise, yeah, stuff partners. Yeah, noise. Interesting. Keep. More within 2 sentences. More data often improves more for more than complex algorithms. Yes, yes, that is what I mean. So basically here it means like data is just more than algorithm. Yeah, that's interesting. I think there is a graph for it. Now noise, random errors on irrelevant can be seen. Blurring math, typos in text. It's so good example. Typos in text. Interesting. So good example. Data mismatch. Oh, I don't think it's data mismatch, not mismatch. It's just mismatch. Training data differs from real-world data. Trains on daytime photo, tests on that photo. Yeah, exactly. That is what I mean. Let's keep it. So category yes, keep. Um, yes. It's about. Oh my god. About grammar, right? Keep. Because introduction to the including. It's about grammar. Keep. Okay. So you see, so this file is officially edited and refined by artificial intelligence. That shows my workflow. I wouldn't say this experience is very ideal, but I think it's very interesting as a workflow. See you next time. Yeah, as I have said, you can't have perfect communication with AI. So you have to do a little bit more after the first try. So yeah, let's go. Let's check how AI reacts. Yeah, let's see. Oh, it's good, nice. He adds more. He add more ideas. I mean, tax classification with few label examples. Yeah, that's it. It's good. So you see, AI now. I think we are approaching almost perfect. AI does a better job. After we talk with it more. We express our needs more in a more clear, in a more detailed way. So I mean, another thing is don't be afraid to like try more, talk more, and yeah, I think that's the end of my video, and thank you for watching if you are watching.